NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve an equation of the form f of x equals g of x using the geometric method. We will graph y equals f of x and y equals g of x on the same axis, and then read the x values where the two graphs intersect. Those x values are the solutions. Here is an example. We will solve graphically the equation f of x equals g of x by plotting y equals f of x and y equals g of x on one coordinate plane. Step 1. Draw a common set of axes and plot both functions. Next, plot y equals f of x as a black curve. Then, plot y equals g of x as a red curve. Step 2. The solutions to f of x equals g of x are the x-coordinates where the curves intersect. Let us mark those intersection points, drop vertical lines to the x-axis, and red approximate values for x. Why does this work? At each intersection, the y value from f of x equals the y value from f of x equals the y value from g of x. That means f of x star equals g of x star at those x star values. We can verify numerically by evaluating both functions at the two x values we found. Summary. 1. Draw the graphs of y equals f of x and y equals g of x on the same axis. 2. Mark their intersection points. 3. The x-coordinates of those points are the solutions to f of x equals g of x. On our example, the solutions are approximately x equals the smaller value and the larger value we found. The solution set for this example is approximately x equals minus 2.81 and x equals 2.31. In this lesson, we will solve a quadratic equation two ways, algebraically and geometrically. We'll also keep our steps neat and clearly labeled like a high-quality solution document. First, here is the example we will solve. The problem states, open parenthesis x minus 1 close parenthesis squared equals 1/2 x plus 1. Before we start, here is a quick challenge. Can you predict the first algebraic step we will take? Step 1. Expand the left side and rearrange the equation. We'll show the rule, then write the line. Now move all terms to the left side and simplify the coefficients. Next, factor the left-hand side, then set each factor equal to 0. Finally, solve for x from each factor. We obtain x equals 0 and x equals 5/2, which is 2.5. Now, let's verify the same answers using a geometric method. We will graph both sides as functions of x and find their intersection points. We draw axes, then plot the parabola y equals quantity x minus 1 squared and the line y equals 1/2 x plus 1. We will mark the intersections at x equals 0 and x equals 2.5. Those intersection points confirm the same solutions as the algebraic method x equals 0 and x equals 5/2. Render all geometric method for solving quadratic equations. We will solve the equation x squared plus 2 equals 0 using a graph. The core idea is to rewrite it as two functions, y1 equals x squared and y2 equals -2. Where their graphs intersect gives the real solutions. Let's build the coordinate plane and draw both graphs. Here are the axes. First, the parabola y equals x squared. Next, the horizontal line, y equals -2. We'll label both curves clearly. Notice something important. The lowest point of the parabola is at the origin 0, 0, so the parabola is never below the x-axis. The line y equals -2 lies 2 units below the vertex. Since the two graphs never meet, there are no intersection points, which means the equation has no real solutions. So the equation x squared plus 2 equals 0 has no real solutions. If we allow complex numbers, we can still solve it algebraically. X squared equals -2, so x equals plus or minus I times the square root of 2. That completes the geometric reasoning and the full answer. Recap. We turn the equation into two graphs, y1 equals x squared and y2 equals -2. We checked intersections and found none. Therefore, there are no real solutions. Algebra confirms the complex roots plus or minus I square root of 2. In this lesson, we will solve a quadratic equation using a geometric or graphing method. First, here is our example. 4x squared minus 8x equals 0. To prepare this for graphing, we first move the second term to the right side. That gives 4x squared equals 8x. Now divide both sides by 4 to simplify x squared equals 2x. Think of this as two functions. One is y1 equals x squared, the parabola. The other is y2 equals 2x, a straight line. The solutions to the original equation are the x coordinates where these two graphs meet. Let's draw both functions on the same coordinate plane and watch where they intersect. We set up our axes. Now plot y equals x squared in light blue and y equals 2x in red. They meet at the origin, and again at x equals 2, y equals 4. Those intersection x values solve our equation. Because the parabola and the line intersect at 2 points, our quadratic has two real solutions. Therefore, the solutions are x equals 0 and x equals 2. Geometric method for solving quadratic equations using graphs. We'll follow a clear 4-step process and solve one example completely. Example: our problem is x squared minus 2x plus 1 equals 0. Step 1. Rewrite the quadratic so that x squared is alone. Move the other terms to the right side to get x squared equals 2x minus 1. Step 2. Define two functions. y1 equals x squared and y2 equals 2x minus 1. Their intersection solves the original equation. Step 3. Graph both functions on the same axis and look for the intersection. First, the axes. Next, draw the parabola y equals x squared. Now, the line y equals 2x minus 1. The two graphs meet at x equals 1 and y equals 1. Because they just touch, there is exactly one real solution. Step 4. Read the x coordinate of the intersection. The solution is x equals 1. As a quick algebra check, the polynomial factors as left parenthesis x minus 1 right parenthesis squared equals 0. So x equals 1. Recap. We rewrote the equation, defined two functions, graphed them, and found their single intersection at x equals 1. This geometric method works for many equations. Convert to y equals f of x and y equals g of x, graph both, and read the x values where they meet. Great work! Try repeating the 4 steps on another quadratic, and compare the number of intersections with the number of real solutions. Geometric method for solving quadratic equations. Example: we will solve the quadratic x squared plus x plus 1 equals 0 using the graphing idea shown in the prompt, and then confirm the exact complex roots algebraically. Step 1. Write the equation clearly. X squared plus x plus 1 equals 0. Step 2. Rearrange to isolate x squared. X squared equals negative x minus 1. Now interpret this as the intersection of two graphs. Let y1 equal x squared and y2 equal negative x minus 1. Step 3. Draw the graphs of y1 and y2 and look for intersection points. We place an x-y coordinate system. The light blue curve is the parabola y equals x squared. The red line is y equals negative x minus 1. Label each graph. Notice that the line stays below the vertex and they never cross, so there are no real solutions. Step 4. Confirm algebraically using the discriminate. 4x squared plus bx plus c equals 0. The discriminate is b squared minus 4ac. Here it equals 1. b equals 1, c equals 1. Compute delta equals 1 squared minus 4 times 1 times 1, which is negative 3. Since the discriminate is negative, there are no real roots. Write the complex solutions explicitly. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.